Hello friends, I am Avaswara. Today we are discussing about the Newton first law of motions. So in this lecture we'll discussing about the Newton first law of motions. So Newton first law of motion is also known as the law of inertia. That so see here, first one is the law of inertia. What is the law of inertia? If the Newton first law of motion is called the law of inertia, we must first define inertia. Inertia is the tendency of object to keep doing what they are doing. If an object is resting, it will tends to keep resting. If an object is moving, it will tends to keep moving. This property is called the inertia. Okay, now magic or physics are that. So why do the dish stay on the table when the tablecloth is pulled out? The dish stay because of their inertia, their tendency to keep doing that they are already doing. So it means that these will not be goes to down. So that's why it is it's inertia of the D's are there. Now try at this your home with the unbreakable disc. Okay, keep in mind it is a unbreakable train. If the breakable train, then your 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 mom will be break you. So keep in mind, use the try this at your home with the unbreakable discs are there. Okay, now see your mass and inertia. Mass is the amount of the matter in an object. The more mass an object has, the more inertia the object has. Now, bigger, more passive objects are harder to start and stop because they have more mass and therefore more inertia are there. So, suppose here the which vehicle has the more inertia we required to stop or the start or that. So, this is the basic phenomena are there. So, see here, if you know about that, if your bike will be off on that time, you need to trying to go another where due to the going to without any fuels on that time you can easily drive and easily you can walk to with your bike and you can go at the petrol pump. But suppose you are using that the trucks are there, okay, and on that time if the truck has a diesel is over, so on that time what you can do, you cannot able to keep with the truck to the petrol pump. So this is the basic phenomena are there. So it's for understanding the mass is amount of matter is an object. The more mass of the object, the more inertia as the object has. So bigger, more massive object are harder to start and stop because they have more mass and therefore more of inertia. So see here there are the two cars are there. So you can see by yourself and you can decide which are required to the more mass, more inertia of that. So see now see a weighty problems are there. See what is that? If you spend most suddenly afternoon at the rest on the sofa watching football and the consuming the large quantities of food, what effect does this productive practice you have upon your inertia experience? See here, your inertia will most definitely increase. Your mass will be increased because of this practice, and if mass increase, then inertia increase. Okay, now the Newton's first law of the motion, also called the law of inertia. An object is motion stands to stay in motion. An object at rest stands to stay at the rest unless the object is acted upon by an outside forces. So the law also say that when an object is moving, it stands to remain moving along a straight line path unless acted on by a outside force or that. So see here the Newton first law of motion, an object at a rest will the remain rest and unless act on by the unbalanced force. See here there is unbalanced force, it is a not force in proper direction, so it is an unbalanced force. An object in a uniform motion will continue with the constant speed and the directions. Okay, so see here unless now see here, we feel the effect of the Newton's first law every day, but usually don't notice them because the other forces interface. In the space, the first law is much more obvious. Object will flow their path until they are acted on by an outside force. On the earth, the atmosphere air frictions will equally slow down all moving objects, but in a vacuum like a place, there is no air frictions to slow down object, and the first law is easy to see. Okay, so see here the law of inertia. For example, now one of the most commonplace people feel the first law in the fast moving vehicle such as a car or bus that comes to a stop. An outside force stop the vehicle, but the passenger who have been moving at a high speed are not stopped and continue to move at the same speed. So on the time, see here what will happen? What will happen? What the seams beyond that time you can see by in this GI in this videos you can see how what will happen whenever the sudden outside forces apply onto the moving things are there. So on that time this is the basic phenomena of that. This is the law of inertia examples are there. So see here. Now the seat belts and the headrest you need them because of the inertia. If you need to go outside, you need to what do you need to do? You need to do via the seat belts. Now here see the law of inertia example. As astronaut in a space throw a rock, what will the rock do? What will happen? It will continue to move in a straight line at the constant speed until an outside force act on it. Okay. So what will happen? If you are throwing to the in the space, astronauts in the space throw the rock. What will the rock do? The rock do it will continue to move in a straight line at a constant speed until an outside force act on it. Eh? So see here, this is the basic phenomena of that. Now see the law of inertia example. Think a ball in a cart. When you jerk the cart forward, what does the ball? Okay, on the time ball, what will happen? The ball will hit the back on the cart. Why? The ball's inertia will keep at the rest while the cart moves under it. Okay. So what will happen? The thing a ball in a cart, when you jerk the cart, you push them on that time the ball will be trying to back to the car. Ball will hit the back to the car. So the ball inertia will keep it the rest while the cart move under the it. Now see here if a force require if you are we are in a weightless environment in a space, would it require a force to set an object in motion? Yes, because even in outer space, an object has a mass and therefore it has an inertia. So, if an object has inertia, then object is going to the resist change in its motion. A force must be applied to set the object in a motion. You are in a space. So, if you were in a weightless environment in space, would it require a force to set object motions? So this is our first law, Newton's first law of motion. So Newton's first law of motion state that things will continue to do what they are doing unless an outside force act on them. So this is our basic phenomena. So see here, there are also second part of that of Newton's first law that state the object will move in a straight line path unless act upon by an outside forces are that. See here, the planet and planetary velocity resultant vector. It is a centripetal force are there. Okay, it is the velocity of the angular motion are there. So this is the what will happen. It is a straight line path unless act upon by an outside forces are there. A rock is being whirled at end of the string is clockwise directions. If the string breaks, the path of the rock is what? In which direction it will be goes? When the break will be when what will happen? A rock is being whirled at the end of the string of in a law in the clock. So directions if the string breaks, the path of the rock is what directions? So see here, if it will flow an inertial path, so it will be path C. See, this is the it will be path C. Once the rock leaves the string, there are no unbalanced force to affect its motions. It will continue in the straight line path until another force act on it. So now take your understanding when the discs remain on table, when you yank the tablecloth away, you are illustrating the law of. Now second thing is that what is under inertia. It's your questions for you. You can write by yourselves. Okay. So put Newton's first law into your own words. As mass increase, what happen into inertia? If gravity between the sun and earth suddenly vanish, earth would continue to moving. So there the options are there. So check your understanding. Okay, you should know what inertia is, the relation between inertia and mass. Second thing is what the Newton's first law states. Then after real world example of inertia in action, tablecloth example, ball in cart examples. Okay, look like that. Now fourth is that what happened when an object going on a circular path because of an outside force has that outside force taken away. Rock on a string example. So this questions for you. You can solve by yourself and you can submit it to the due to the PDF. So thank you guys, thank you so much.